Hi, on behalf of 24 Hour Answers team, I would like to welcome you to today's lesson. Today's lesson is capacitors number 2. In previous lessons, we have covered what capacitors were. Now we're going to explain what stored energy is and what happens when capacitors are connected in series and parallel. If we have a capacitor connected to a battery or a generator, the amount of energy stored in the capacitor is equal to the work done by the battery or a generator to charge it. Without going too much into details regarding the calculations for work performed to charge a capacitor, we have this formula. You can see it on your screen. W equals to Q squared divided by 2 times C. If you remember, Q equals to C times U. Now we can write the formula for work in another way. W equals to Q squared divided by 2 times C, or C times U squared divided by 2, or Q times U divided by 2. All that equals to EC. Bear in mind that if we connect our capacitor to a light bulb, it will slowly discharge, but the light won't be constant. It will start to fade away. This can be explained using the formula U equals to Q divided by C, or the less charge we have in our capacitor, it kind of gets spent, the lower the voltage. Take a look at the picture of a capacitor on your screen. Let's take a look now at what happens when we have our capacitors that are connected in series. Well, first of all, capacitors in series, they share the same charge Q, as you can see that on the picture on your screen. The equivalent capacitance can be easily calculated. We will start by summing up all the voltages from the capacitors. And you can see on your screen every step that we did. In the end, the final formula is 1 divided by C equivalent equals to U divided by Q, or 1 divided by C1 plus 1 divided by C2, and so on, to 1 divided by Cn. Now let's take a look at what happens when we have our capacitors connected in parallel. Well, first of all, capacitors in parallel, they share the same voltage. Equivalent capacitance can be easily calculated. We'll start off by summing up all the charges from capacitors. The rest of the steps you can see on your screen. The final formula that we get is C equivalent equals to Q divided by U, or C1 plus C2 plus and so on until Cn. That should be it. Thank you for your time. Check out our YouTube channel for more lessons.